Hi, William. Nice to meet you again.
Nice to meet you.
Now, thank you so much for taking a few minutes for this. Before we delve into all of the exciting topics for today, let's learn a little bit more about yourself, if that's all right. Would you mind just giving us a brief context to who you are and what you've been doing the past couple of years?
Yeah, sure. Um, I get into automotive, especially the EV boom in the past probably 4 to 5 years when I uh, step into the shoe of Foxconn Group's CTO for them to want to get into the software-defined vehicle world. So basically, 2020 in October, I kick off the first tech day, announcing that we are starting out this journey of software-defined vehicle as a what I call it the Android of EV Open Platform. So that was an exciting time. We got the overwhelming receive from the international community, especially the software sector, such as ARM, such as AWS. A lot of uh, team that wasn't able to get into automotive, they join what we call MIH, this platform, to define the future of software-defined vehicle platform, including the digital native cloud development of all these components, including autonomous driving, simulation, the DevOps, kind of the development lifetime in the cloud. And also, of course, at the end, we have some hardware vendor that support us to do this hardware in the loop kind of development. But mostly coming from the whole background is coming from my background early on. Back in the day when I worked for Steve Jobs in Next Computer, that was a before pre iPhone era. So our goal is to have a really agile, rapid prototyping platform, right? To establish for the enterprise sector, everybody can do using all this platform like ready build sort of software IC kind of idea back in the day with object-oriented development methodology, starting out from small talk, right? So back in the day, we our platform is called the language called Objective-C, which is Apple kind of predated Apple Objective-C development, and that is modeled after Smalltalk. Everything is object, everything is dynamic, right? So from that system building kind of a mentality and also the software IC kind of mindset, we have a next step. We call it next step, and we have software defined everything, including the OS layer is abstract. So we can port our OS to any silicon at that time. That was 30 years ago, right? So after 1997, we were acquired. Actually, the end of 96, we were acquired by Apple Computer, right? And that's the story, the beginning of iPhone development. Predate, 10-year predate announcement of 2007. And based on that platform next step, at that time when we acquired, already changed name to OpenStep. And based on the OpenStep, the OS and SDK, we announced iPhone 2007. And then we also have iOS SDK, which is a really reliable, robust framework for any application developer to come in to build any iPhone app, right? They don't need to build a system layer. So that's the idea come from, right? So I coming from the long time Apple system developer, tool maker, jump into automotive. And I want to build a similar methodology for automotive industry.
That's
So
fascinating.
moving forward. Yeah.
No, thank you so much for the context, William. That's yeah, such an inspiring journey. Let's start with sort of some of the fundamentals. If you would have to explain what software-defined vehicles are to someone who doesn't work in automotive, what would you say and why? Why do they matter? Slash, how do they present a disruption or change to the incumbents in the industry?
Yeah, sure. Software-defined vehicle, there's a lot of definition from a different angle, from different industries, especially automotive industry. It's kind of a new concept for automotive. As I understand, they are more dealing with a mechanical world than the software digital world. And by getting into a software-defined vehicle, meaning to me, meaning like we develop a automotive system just like the today's computer system. You know, a smartphone like iPhone, it's no longer a phone. It's a computer. You know, it's a mobility computer with that you can dial and you can call. That's it. That's about it. Other than that, it's a modern computer, right? So if you say it's that the hardware is a phone, but everything is software defined, you can software define calculator and turn into that hardware into a calculator, right? You have all kind of application that is all software form, but at the end of the day, using the iPhone, it achieved the goal of what software wanted, right? So back to the if you extend this concept to automobile, it's an automobile, right? But you can on top of automobile, you can write autonomous driving software, right? And that software can be using purely a software methodology to OTA it. In automotive, we call it over the air to turn this, to download this or upload this software into the cloud and push down to your automobile. And then your automobile become a self-driving robot, okay? And your automobile can turn into a smart living room, for example. For all, like Spotify can come in, you know, all the a software world that we enjoy, you can turn this automobile hardware into that kind of functionality. So to me, that is a software-defined world, right?
No, thank you so much. That's super helpful to set the scene. What are some of the sort of big trends and challenges that you see incumbents are facing in the space? You've recently delivered an AI first SDV talk in Detroit. What were some of the sort of key takeaways from that?
Yeah, thank you for bringing that up. So that was 5 years ago, right? When I started out this software-defined open platform for third-party application developer in all kind of domain can jump in to develop their domain-specific application. Now, today, 2000, I think the beginning of 2024, this year, is the AI era. You know, we officially announced the AI era. To me, the AI era is to replacing this deterministic world of computation into this kind of probability domain of probability problem domain, which AI try to solve. So AI is a reasoning machine that it kind of solve all kind of problem using probability, meaning that can you solve this specific problem with not 100%, but 99.999 as far as optimization can push forward, right? So anything is in AI domain is not deterministic. It's probabilistic. So because the today modern Gen AI it's a great reasoning machine to solve all the probability domain, and in our universe, I believe we have more probability domain problem than deterministic problem. Any very complex problem like autonomous driving, self-driving car, it's not a deterministic problem, for example, right? So that's the sort of Gen AI era of the development world using Gen AI to solve this problem. So on top of the software-defined world, we already have a cloud-native concept. We already have this kind of a traditional DevOps development life cycle. You know, it would be even great to add on top of that digital world to move into a Gen AI world, what I call AI first SDV. What AI first meaning, everything that you think of, all the domain, you think of AI, using AI to solve it first. Okay, so that's the concept of AI first SDV that I try to communicating or discussing with the development community.
Really interesting. Which leads me to my next question. What is your vision for the future in-vehicle customer experience? How do you believe AI will transform how we as individuals, whether owner or user of a vehicle or both, will change how we engage with the vehicle and surrounding system?
Yeah, you know, coming from Apple, I have very strong DNA of user experience, right? We try to solve any problem to provide the best user experience. So let's say automotive, if automotive vehicle is a computer, right, with functional safety, very strong functional safety requirement. Let's look at the system like that. Now, does the AI, the new user experience of Gen AI apply to this most expensive, I think, personal device, more expensive than a cell phone, maybe 10 times or 20 times. How do you, for the developer, how do you see this device? What kind of computation power? First of all, what kind of computation power do you imagine that device has? And on top of that, if it has layer of OS, has a layer of middleware, has layer of service layer, and you put the Gen AI engine, which is a large language model, which today is a multimodality. It can see things, it can hear things, it can reasoning. If that is the ideal development platform, what kind of application that we're gonna bring in for the user experience? That, you know, really lead me to the Star Trek era, right? Growing up with the Star Trek, how do you interact with this powerful computer in Starship, right? How do you, and also like a Knight Rider, right? How do you interact with your car? You just talk to your car and your car understand what to accomplish and just do it for you. Instead of a big giant screen, like a huge iPad screen, and then you kind of command it to do something using touch screen. I mean, that's the big difference. You know, you start using kind of communication, voice or audio communication, or some other kind of implicit communication with your device. Say, hey, I'm hot, I'm really hot, make it comfortable, right? For this kind of expression, how does the computer itself make your user experience cool? That this machine understand you, and then you don't need to go to open the screen and swipe it, and then jump into another sub screen, and then pick whatever subset you want to accomplish. This kind of paradigm shift of interacting with a super powerful computer. That's the paradigm shift that I try to communicate with both the user and developer, right? So in AI application, the first thing will be like Siri, right? I think about Siri almost 30 years ago, 2008. That was the first time that Apple introduced Siri, acquisition from a small team out of Massachusetts. And at that time, there's no, Gen AI. At that time, it's an expert system that just doesn't work, But the idea is Siri finally can work with, human being. And I'm excited about this. Right.
Sounds like a very optimistic outlook on the future, which is in some areas quite far away from where we are today, which leads me to the question of where do you believe this technology is coming from? Do you believe this is something that the incumbent automotive manufacturers will develop internally? Do you think this will predominantly come from the technology companies or entire new organizations? How do you think this plays out?
Yeah, I think this has nothing to do with the automotive industry.
Okay.
What I just described, it include automotive industry, but not limited to the automotive industry. For example, a smart space like smart home or smart office, or any, the future AI device that you interact with, it's gonna be fall into this kind of new paradigm of interacting with a machine that kind of really understand you, right? You can push even further down the road, like neural link. You don't even need to, you just need to think about it and it accomplish what you need to do, right? That's another far away interface. But right now, at least between human and human, we communicate with a language is fine, right? It's good. Like your really human being personal assistant really understand the boss, what the boss want. You just kind of have this kind of not deterministic command, but kind of a you express the kind of intention to your personal assistants, right? Say, hey, accomplish this, do some reasoning, and I just want this to be done, right? And I think that's not far-fetched away. Today we have, if the idea is, okay, if we truly dealing with the what I call software-defined vehicle 1.0, meaning it's a open API kind of system, right? All the function and system, the sub domain of feature, it's an API, but it's a dumb API, but really robust API. Now you have this really smart reasoning machine understanding what you need to be done, and it will compile all this sequence of things to do that understand what API to call to accomplish this complex task. For example, ordering a pizza, for say, like, you need to go to web research and then online, and you pick whatever favor that the user want, and go down to row and maybe interact with the user a little bit to fine tune what the exactly pizza or amount that want to order, and when, where, why, all this compile into a command and just a shooting sequence of API to accomplish this ordering and deliver to you. For example, this is a pretty complex task that today, not automotive, but any other system can use, as we see a lot of different demo, OpenAI demo for you. It can order a strawberry, for example, for the party, and to kind of separate this open API and then reasoning machine, and you kind of glue them together. It's sort of the Gen AI smart assistant application already today delivering, right? So we need to continue to add open API for different domain. For example, I have a video demonstrating I'm talking to this smart agentic auto assistant going through LM, coming out with a sequence of in automotive world, the CAN bus message to control, open the window, close the window, turn on the fan, all this body domain, right? That's my demonstration that is working proof of concept. You can go this even deeper to like your battery domain. How do you optimize your battery operation? Collecting data and show some API, what's the voltage, the current, all this. If today there's no such API understood, it's all closed in a closet, try to be a closed system. The logic itself, it just doesn't change over time. But in Gen AI with LM, it's all this API is generated dynamically. It's not a fixed compile application. So that again, is reachable today. That's really exciting. For example, smell, you can add modality of the smell, the sense, right? Then you can control if it smell bad, you need to control something in the sensor, and then the output with air quality control, things like that. I think people will if you build a kind of API, people will be dynamic, have some kind of a reason and agent to accomplish whatever you like. Just out of my mind, just out of my on the spot, I'm thinking, a smell, it can develop in the future. Not just audio, like smell can be API as well. Yeah.
All of these fascinating use cases and examples that you've described lead me to sort of a question of what is left for brands to really differentiate, and what are the implications for the competitive landscape in automotive. For context, I guess we've largely had sort of the reasonably similar players over the past 100 years in the automotive industry. Over the past few decades, we've seen some consolidation with organizations or alliances like Stellantis and PSA and so on. And then we've seen over the past couple of years some new players entering the space, especially pure EV focused manufacturers. These SDV and AI, Gen AI related examples that you've described and the general developments that, as you suggested, we already see in some industries to some extent. What do you think are the implications for the competitive landscape in automotive? Do you think this will change, not change? How do you think this could impact that landscape?
I think it's definitely changing, because like you say, all the prominent used to be dominating the automotive space for so long, because they in what I call ICE era, and now it's you take out the ICE, the technology itself, by moving this skateboard, become just motor and some control. I think it simplify a lot of a mechanical domain. Okay, so and then you open up the HPC, to get into this this vehicle with huge say 100K watt of a battery. Imagine how much you can do with just a a smartphone, iPhone today, right? The battery lasts, say, 8 hours. There's a tiny battery lasts 8 hours and accomplish a lot of tasks. In the automotive industry, besides driving the car, you can do a lot more. If you solve, right, autonomous driving, which Tesla, Waymo, a lot of this what I call AI-driven autonomous driving already accomplished at least level 2, right? Level 2 plus. Now they want to get into maybe skip level 3 to the totally level 4 without the steering wheel and gas pedal. This is just one agent. And we can introduce all different kind of agent because there's a supercomputer on board, right? We introduce health, some biometric sensor, and also some health related or anything that interests in the future driver component, because today car, all the sensor, all the component is focused on just driving along. Maybe IVI is another entertainment sector, which is speaker. The mic doesn't really work, right? There's no mic in the car today. In the future, they're gonna be very directional mic. The mic is gonna pick up the voice in the different passenger. It can allocate who is talking with this kind of identity, the rich world of interaction in the cockpit. So I think the destructive force is coming very soon if you have this kind of open architecture, just like Linux, right? Everybody can jump in. But today's, I think it's the trend is set, but it's just timing. I don't know when, all this OEM decided to do it this way. I understand that they have a lot of pressure from the traditional OEM tier system, the supply chain, tier 1, tier 2, there's a lot of social responsibility, but pure technical speaking, it can happen really fast. When somebody opened up, imagine, okay, today, Tesla is the first SDV that, when we call over the air update, this is SDV, then Tesla is the first SDV. Today's Tesla is what I call before Nokia Me iPhone, Nokia Me Apple, right? When iPhone first introduced, it has this modern computation core and modern development platform, which Nokia doesn't have. Before they have an app store, which is open up for all the third party. Today, Tesla doesn't even open up for third party. I believe in Tesla, there's some kind of a close they themselves in Tesla has OS layer, has SDK layer that they use by themselves. If they open up just like Apple did in 2008 with the App Store, so and then upgraded to really truly Gen AI kind of development platform. You're gonna introduce a lot of different third-party agent to come to play in this platform. So Tesla today, the leader doesn't even match the iPhone back in 2008. So there's no Android of SDV. If you have Android SDV, that's my vision, 5 years ago, that all the very disrupted force, third party can come in to move this automotive industry faster into the future robotic. Yeah. So I think it's just a matter of time, but I don't know the time.
What are some of the big future trends that you see in this space? Just for context, currently I hear a lot of conversation about technologies like quantum computing, more edge computing, more sort of smaller language models that run on devices for particular use cases. We've had lots of conversations about blockchain and use cases in the context of automotive. And there are so many more. I could go on for hours. What are some of the
Yeah.
sort of big future trends that you believe could realistically stick in automotive?
I think it's the edge computing. I think it's the, once you have deployed the true Gen AI infrastructure, starting from silicon, right? Not just a CPU, but CPU with NPU, with a language process unit that can truly accelerate the local LLM. So that's one piece. Once you have that kind of computation horsepower, optimize it, accelerated computing platform, which I believe beginning next year, 2025, you're gonna have a lot of ASIC chip on the edge to accelerate transformer-based architecture. Now, the other piece will be the foundation model. So today, the frontier foundation model that has really close to AGI reasoning capability, maybe we just a few years away from AGI. Those are frontier model live in the cloud. How much intelligence and reasoning capability can you squeeze into smaller foundational model that you can put on edge? I think that is really critical, and that is happening right now. Today's 2B, Llama 3.2, 1B or 3B model already can carry out some function calling, really robust function calling, like I have demoed it in my video, the POC. Imagine like in a couple of years, if you can really fit in this reasoning LM into edge computing, then agentic with agentic kind of a framework, the SDK, agentic SDK, that people in a different domain can come and use, develop all different kind of agentic AI. I think in 2 years we're going to see something amazing happen. Of course, in automotive industry, you still have to solve this deterministic functional safety model, which is not really fit well into this probabilistic model, right? Everything need to be 100% tested. There's no corner case and then not being tested. It basically is a state machine. But in the AI world, it's not state machine. It's a probability model. It's really depends on human being, the responsibility of functional safety, how safe is acceptable, in a probabilistic model, like 99.999, how many digit a safety guarantee, like in a aviation model, right? Aviation, there's no guarantee that 100%. It's safer than driving already. Right? If you can reach that kind of a probabilistic model that acceptable by functional safety, of course, before that happen, you need to introduce a guardrail, between this Gen AI agentic world and your robotics, this traditional functional safety module. There's a layer there you need to guardrail against before anything happen. So I think it's a gradual progress of this Gen AI agentic model. Is it happening? It's just how many percentage is progressing. Yes.
Final question from my side. Imagine that you're talking to the chief data and AI officer at one of the incumbent automotive manufacturers who is in charge of the organization-wide developments on AI and also Gen AI and the associated strategy. What would be your top 3 recommendations to him or her to unlock the most value from these technologies that we've spoken about in a sustainable way?
Yeah, you say 3 things?
You can pick more or less if you want to, but yes, around 3.
Yeah, a couple of things. The first thing is you don't need to throw away your traditional way of in a vehicle control domain specifically. It's acceptable today for ADAS, like 2.0 plus, that kind of functionality, like driven by AI. Okay, it's great. Today, a lot of people already using ADAS, the Gen AI based ADAS on the highway without, it's just replacing already. It's already replaced with this robot deterministic PID hand-coded control of experience. That is done, right? The other part is the crowded street, maneuver type of ADAS, which today is progressing every year. I think just keep that until that really people proven the safety level reach some kind of a threshold, 99 point, maybe 3 more digit 9 of this model by statistic. And then it's good to accept that the fact that we are reaching AI end-to-end model can take over. So before that, we can continue that kind of trajectory. But the second one is open up this development methodology of open AI, open API with SDV, right? So basically you can define a lot of the different domain using open API, and then let the application layer either you develop using traditional application and compile this API to compile application. So you have this traditional way, but really once you open up the API, we can introduce a Gen AI agentic agent to come here to dynamic deliver the functionality in outside of a functional safety world. There's so many things that users are willing to pay for it, I believe, in this smart cabin experience. So, so this is that if I were talking to this the chief of technology, especially the traditional OEM, the sooner they do it, they won't die because they already we can see Carrier is a failure, and Toyota also have a similar experience. So everything is they want to do it at once, right? Replace all with this new modern what they call OS. I don't even know what is a vehicle OS mean. To me, it's not OS. It's all kind of open API services that operating this car, but it's dumb, really robust, but dumb API services that open up, and then you use the this reasoning machine to compile a really safe kind of a program agent can deliver all the experience. Again, I will say it again, outside of functional safety first. Yeah.
Thank you so much, William. That's been a fascinating conversation. I really appreciate your time and insights today.
Yeah, I didn't prepare kind of structure interview, but just throwing out things on top of my mind. I hope
No,
we have meaningful conversation so far. Yeah,
that was really good. Thank you so much.
thank you.